Hello, everyone. GM and welcome. Hope you're all having a great day. Please voice off in the chat section below. My name is Yasen, and we're about to kick off the Internet Computer Chain Fusion Hackathon finale, something that we've been working hard on for the past 5-8 weeks now. It's been a long time. There's been a lot of building going on. There's been a lot of hard work happening, a lot of great submissions, and we're finally at the point where we can see the best of the teams presenting their best pitches. Hope you're all having a great day. Hello. Nice to see you all here. Again, for those of you that have not been to any of our programs, just a couple of words on Encode Club. We're a global community of top developers, professionals, and a lot of talented students, mainly focused around emerging tech. We do a lot of all kinds of different programs as an Educate series, which help everyone to kind of experiment with a lot of technologies that previously not been exposed to. We then put these people through hackathons to put their skills to the test, see what they've learned, see what their imaginations allow them to do, and win some prizes along the way. And the best of these teams we usually put through a lot of accelerators. Accelerators are for some of the very best teams ready to polish their ideas, and as they walk towards on the road towards becoming a startup. We do all kinds of boot camps. These boot camps are mostly meant for people to refine their skills or to learn some new ones. And lastly, we help a lot of our community members with recruitment through all kinds of career fairs and a lot of one-to-one calls to help them get a place in the Web3 industry. Our community is now growing to over 500,000 strong, and they both span across the Web2 and Web3 industries. In today's event, we are finalizing a great hackathon, the ICP Chain Fusion Hackathon, which was a 4-week endeavor, which was centered around leveraging the Internet Computer's new chain fusion technology to build all kinds of multi-chain dApps integrating ICP with Bitcoin, Ethereum, or any of the other EVM chains. We've had a lot of great submissions. There's been a lot of reviewing going on, but we've managed to narrow it down to the very best, which we will be seeing today. Our great sponsor, the Internet Computer, was the one that reviewed all of your submissions, and as I said, picked the very best. And I would like to introduce on stage Jennifer Tran, who is the developer relations representative from the Internet Computer team, to share a couple of words for all of you that are attending today and will be pitching. Jennifer, you should be seeing an invite on your end popping up at the moment. Everything should be running fine. Hello. Great to have you with us. You are muted, by the way.
Hello, Yasen. Thank you so much for having us today. I'm also joined with some of my colleagues in the audience as well, Emma and Elias. So yeah, we'll be hearing you guys pitch. As you guys already know, Internet Computer is a Layer 1 blockchain that also serves as a decentralized crypto cloud. So what you guys use in your projects is the Chain Fusion feature, which allows internet or ICP smart contracts to actually communicate with different chains, Bitcoin, Ethereum, EVM, as in the future, also Solana, Cardano. We integrate ECDSA and Source signatures, and in the future EDDSA signatures as well. So excited to kind of see the finalists pitch. We saw a really variety of great projects, and we invited 6 teams to actually pitch today in order to secure the final prizes. And so we'll hear from you guys, and then we'll let you guys know who's winning.
Perfect. Thank you for coming on stage. Jennifer will be one of the jury that will review all of the live pitches that we will see today. And we are now ready to begin with the pitches. So we'll start off with inviting the teams one by one to the stage, and starting off with Team Oreka. So let's have Kyla on stage to present.
Okay. So, hello everyone. How's it going? My name is Kyler. Today, I will introduce you guys a prediction market layer on internet computer or a multi-chain infrastructure. So here is our current landscape. We have a Poly market. It's the leading platform for prediction market. We have many new prediction markets that appear on Solana. So we identify the gap in the market here because ICP lack a solution for derivative. So the problem is ICP lack limited infrastructure. Example, BETDES have a prediction market, but it doesn't have any verification on smart contract, so it's a trust issue. We have limited Oracle for betting price feed. We have Orally, but it only supports weather prediction. So let's introduce Oreka. So Oreka vision is help developer build their prediction market. We have some core features such as advanced Oracle request, smart contract component, and liquidity hub. So in our Oracle, Oreka will utilize HTTP ALCA for fetching reward asset. And we have smart contract component preview for quick deployment and unify or separate liquidity. So we have a demo here with binary option market for Solana meme coin. First, we connect the wallet. We select the WIP USD from Solana meme coin. Then we deposit the ETH here, ETH from Anvil. After depositing, we can choose up or down. The market will be resolved in 30 seconds, and it should be resolved by the owner. So after after 30 seconds, we will have the result. Or one you win or you lose. It's just it. So it's one of the prediction market on Oreka. You can check the demo here for more detail. So our roadmap, we will deploy smart contract template, factory, liquidity hub, and collaborate with other ICP projects. And we can go cross-chain. So we hope to empower developers to build prediction market and other DeFi derivative on ICP or cross-chain. Thanks for watching. Okay.
Thank you, Carla. That was great. Appreciate the presentation, and moving you back to the audience as we move on to our second presenter for the day, which is going to be Thomas from A Data Layer for the World. Thank you, Carla, once again. As we proceed, Thomas, you should be seeing an invite.
And now you should see the slides, correct?
Yes, all visible, and you're ready to start when you are. When you're ready.
Cool. Well, hi. This is the Data Layer for the World. I'm Thomas from Berlin. So 1 second. No, slide didn't go. So okay. Yeah. So current map apps, they inform us where to drive or where to shop, but they cannot help us in deciding on which plot of land to best build our house, or which city area needs community development. Also, they cannot help us to donate directly to a disaster area or to be rewarded for sharing local information. So there is no data for such decisions like flood or hurricane probability on a specific area, air quality, or how many dengue outbreaks were here in the last 10 years. Also, there is no support for location-based value communication, meaning donating to a specific area, or this is then distributed to, for example, area residents after a disaster. Or it's not possible also to enable area stewardship so that people care about a specific area. For this, we need an open, trusted memory and value map. The Earth divided into squares. Each square holds static information on an NFT and changing data on IPFS. Everyone can read it, and writing is governed by the internet computer logic. You see here now the architecture. So you have users and other agents like cars. They use the internet computer stack, meaning internet identity, the front end or API, the creation and handling of the squares, our areas, I called them before, the minting and handling of the NFTs, and handling of balances and transactions on the blockchains. Also, of course, updating the dynamic information about each square on IPFS from sensors and APIs. Therefore, each square has its own interplanetary name system name that points to changing content IDs on IPFS when the data is changing. For this hackathon, due to limited time, I implemented a limited version of this. A quick demonstration. You see here a React app. You can input geolocation manually or fetch it from the client. This geolocation is then mapped to a specific square on the world. You see here the static information, the NFT information of the square. You see the geohash. This is the ID of the square, if you will. Then you have the IPNS name. And for now, you have a Bitcoin address and an Ethereum address for the square, for each square, a different one. Here the dynamic information or real-time metrics. So for one, you have the balances of these addresses, and then you have, for now, some mocked metrics like air quality index and a rating. This is a user-generated metric. So if you log in with internet identity, you will be able to change the user rating for a specific square here in the front end. For a longer demonstration, please watch the video. I will paste some links in the chat afterwards. Yeah, what's next? First of all, of course, build out the whole architecture that I showed you, and then a lot of testing, a friends and family testing phase to further scale it up afterwards. Thank you very much.
Thank you, Thomas. That was great. We are now moving on to the third presentation for the day. Thank you, Thomas. I'm moving you back to the audience, which is going to be ICP-EVM Rust Bridge. And we have Devin here to present along with Steve. Giving you both invites. I know that only one of you present, but as promised, I want to give you all the recognition as you've both worked real hard in the project.
Yes, so I hope I'm audible and my screen is visible.
Yes, you're free to start.
Awesome. Yeah. So hi guys, we are presenting to you the EVM Rust Bridge, your gateway to multi-chain dApps. The team members are personally I, Steve Kimoy, and Isaac Tevin. So our inspiration comes from when developers will want to build multi-chain dApps. They normally take it normally takes weeks, if not days, for them to configure everything and set everything up in order to start building out the product. And the work of a developer relation is to simplify the work of developers. And developers normally require easy, fun, and streamlined building process when it comes to interacting with that particular technology that they'd like to use in order to develop their application or their website. This is why we created the EVM Rust Bridge, a toolkit that allows developer to easily build and maintain multi-chain dApps in a matter of minutes and seconds. So how does it work ideally? The first step is for the developer to go to and fetch out the bash script command, paste it in their terminal and run it. Once the command runs successfully, it configures everything, it deploys everything locally. That is the EVM RPC canister, the local canister that they will be editing, and also the front end part. And once it has been deployed locally, they can quickly start editing their ICP canister code to call the specific EVM-based smart contract that they'd like to interact with. This is a screenshot of our live site, which just displays how the whole system works. So it contains a canister, a get canister ETH address button, which displays the ETH address of the backend canister, and it contains a get count button, which is part of the read functionality. So if you'd like to see how a read functionality is being performed from the ICP canister to the EVM-based smart contract, you can utilize that particular get count function. And we also have the functions that display how someone can perform a write functionality from an ICP smart contract, an ICP canister to an EVM-based smart contract. And in order to display the validity of the transactions that are happening, once the developer has generated the Canister's Ethereum address, they can click on the different transaction hashes. So if the developer has set up their project locally, initially it won't have the transaction hashes. But once they perform the transactions, it will be able to store the transaction hashes, and they can click on a particular transaction hash, and they can compare the different Ethereum addresses. So they can see the Canister Ethereum, the backend Canister Ethereum address, and compare it to the Ethereum address that is present on Etherscan in order to confirm the validity of the transaction. So this clearly shows that the particular functionality happened directly from the ICP Canister smart contract to the EVM-based smart contract. So the different advantages of using this particular toolkit is that developers are able to save hours, or to save a lot of time when it comes to building multi-chain dApps, since the developer hours are reduced from hours to seconds, and it allows the developers to specifically focus on the product itself, since the main functionality has been abstracted. So the main functionality when it comes to calling the EVM-based smart contracts has already been done. So the developers will only focus on the product itself. Our roadmap is to have a Motoko version of the toolkit. So currently we only have a Rust version. We also would want to work closely with the DFINITY team to have it being a part of the DFX command line toolkit. So when a developer clicks on DFX create new project, it will be part of the toolkit. We'll also be maintaining the toolkit and updating it with the latest Rust versions, and also we'll be adding new features based on developers' experience on utilizing the toolkit. Thank you.
Thank you so much, Steve. Thank you, Tevin, as well. Great presentation, and we're now moving to team number 4. Moving you both back to the stage, appreciate the presentation. And now we're going to have Slavik with AMM Heartbridge.
Okay, my project is Heartbridge. Heartbridge is a bridge based on ICP Chain Fusion. This ability to swap native tokens from one chain to another with minimal time and fees. It is cross-bridge. It's not specific network-to-network bridge. So we will be able to swap from to any networks supported by Chain Fusion. For start, only EVM networks will be supported. This is permissionless, so users don't need approval for bridging tokens, adding or removing liquidity. It's AMM, Automated Market Maker, like Uniswap, but not for ERC20 tokens, for native tokens at different networks. Any user can provide liquidity and receive profit from swap fees. Joint liquidity, but in comparison with Uniswap, we don't need to have separate pairs and liquidity pools for each destination. All destinations have it from one pool at each network, and swaps did through internal synthetic asset. It's native. The bridge supports native tokens only to decrease swap fees and avoid token manipulations. For example, almost all stablecoins can be blocked, and if bridge contract will be blocked, it can stop all bridge traffic with this token. So hard bridge cannot be locked. How it works? User calls bridge contract function from UI or from smart contract with value to transfer. Contract just fires bridge event with data. ICP canister with Chain Fusion catches bridge event, calculates amount out, and transfers network token to user on the destination chain. Why use hard bridge? Because it's truly decentralized and immutable. Cheap, as we use simple smart contracts and native transfers only. It's fast. Events not only scraped by timer, but will be pushed by WebSocket notifier. It's good for users, traders, liquidity providers, and arbitragers. Thank you for your attention. That's all.
Thank you, Slavik. That was great, to the point, well made. Moving you back to the audience, as we now proceed with the very last of the presentations for today, which is going to be AstroApe. Anthony, let me know if you have any issue. Oh, you're here. Okay, perfect.
Yes, can you see me, guys?
Yes, I can see you and I can hear you as well.
Okay.
Feel free to share and take it away.
Okay. That's fine?
Yes, that's great.
Okay. So I'm Anthony from AstroApe. AstroApe is a multi-chain meme coin deployer on Internet Computer Protocol, whereby we chose ICP as our base chain. So we set out to solve some problems, which are drag pools, high gas fees, lack of liquidity, whereby developers don't have enough liquidity to launch their token. We also have vulnerable bridges, which are oftenly hacked. We have lack of transparency governance, and limited cross-chain interoperability. So we have a very simple UI for our users to use, since we are a community-based project, and you're able to launch token easily without no code. We have zero liquidity, so you don't need any liquidity to launch a coin in our platform. We have a dynamic bonding curve that allows you to launch with zero liquidity and just $1. Also, we are utilizing Chain Fusion technology to bridge assets from Ethereum to ICP and other chains. We also have a multi-chain governance that allows to govern and vote for new features. So why did we build on Internet Computer? This is because of the Chain Fusion technology. There's the reverse cast model, and there's verifiable credentials, which is going to allow us to airdrop our token, our utility tokens, without symbol attacks. We also have AI on the blockchain, which is going to help our traders to trade easily. So how does this work? So when you come to our platform, you're going to deploy a coin under $1. And all you need is a token name, token symbol. We have a description, choose a banner. Then you're going to choose which network to deploy your coin on. So whereby you can choose between ICP or Ethereum. And you can go ahead and choose a decentralized exchange where your tokens are going to be deposited. You're going also to snipe a few of your tokens. Then you can input the websites, the Telegram, and the Twitter for your communities. So there's going to be 1 billion token printed, and 80% are going to go on the bonding curve, whereby 20% are going to be deposited on the DEX after it achieves 100% on the bonding curve. So for Ethereum users, once you come to our platform, you can bridge your Ethereum assets to ICP, whereby you wrap them from ETH to CK-ETH. Then we have our bonding curve, whereby you can come and buy tokens, whereby the price of the token is determined by the position you are at the bonding curve. As tokens are bought, the price goes up. As the tokens are sold, the price goes down within time. And it has to reach $69K for it to achieve 100% on the bonding curve. This will raise around 21K liquidity, which is going to be deposited on the decentralized exchange. So what happened after the 100% has been achieved on the bonding curve? The trading is stopped on the AstroApe platform, and the liquidity is deposited on the decentralized exchange and burnt, so that the developer cannot remove liquidity. We also have, on the Ethereum networks, we'll have to create a twin token once the bonding curve is complete, so that we can move it to the Ethereum network and we can deposit it to a decentralized exchange like Uniswap. So after that, the trading will continue on AstroApe, whereby we are going to trade from the decentralized exchange through our platform or trade on the other exchanges. So what's our roadmap? At the moment, we are looking for grants to develop our projects, since we already have a community behind us, whereby after that, we are going to do a beta testing of our product and check for security audits. Then we are going to go for a mainnet launch, and we are going to do a series of airdrops to our early adopters of the platform, early traders, early people who come and launch their tokens, and also go for some series of funding to be able to build other tools for this DeFi ecosystem. We're also going to expand our ecosystem to other networks, e.g. Solana network, the Bitcoin network. Then we're also going to have staking, so we can enable our users to be able to vote for changes on our platform. So thank you very much. That was me for AstroApe.
Thank you, Anthony.
Thank you.
That was the last presentation from the finalists today. And we are now going to be move on to the judging bit of the hackathon finale. There will be a separate room in which judges will convene, which I will make in a bit. In the meantime, let's have Ray on stage. Ray is the founder of Bitomni, and he will be addressing the audience while the jury is taking their time to pick the winners. Ray, I'm going to send you an invite in a second, and in the meantime, I'll also set up a breakout room for our judges. Hello, hello.
Hello, Jensen. Hey.
Hello, how are you doing?
Good. How are you?
Amazing, yeah, and a really, really exciting time. The next 5-10 minutes will be really exciting as the jury will be picking the winners. So you should be able to share screen, by the way, now. You should be seeing on the bottom, very bottom, so that should be fine. In the meantime, as I said, myself and the jury will be in the breakout room to finalize the selection of the winners. Ray, feel free to take it away when you're ready.
Sure, perfect. Yeah, let me try to share my screen here. Still not full screen, right? Or
yeah, it's in full screen.
It's in full screen. Okay, perfect. Okay, thank you. Yeah, sorry for the late. Okay, hello everyone. I'm Ray from Bitomni. Bitomni is a BTC-driven omnichain asset management protocol built on ICE. We have a suite of built-in DApps, including Bito Bridge, Bito Indexer, Bito Restaking, and more. Today, I'm thrilled to be here to talk about one of those, which is Bito Bridge. Let me try to, okay. So what is Bito Bridge? Bito Bridge is a Bitcoin-centric omnichain bridge we've developed on IC. If you are curious, you can follow us on X and check out Bito Bridge testnet. We've just upgraded to V2 like several hours ago. And let's start with the problem Bito Bridge is tackling. So essentially, Bitcoin and its new tokens like Ordinals and Runes and BRC20s are kind of trapped within Bitcoin blockchain. This limits their utility and accessibility. The most popular solution is like WBTC, centralized wrapped Bitcoin. Some cross-chain bridges and swaps exist as well, but most only support WBTC or other centralized wrapped Bitcoin. Don't even think about to support BTC's new meta protocols. That's where Bito Bridge comes in. It's our decentralized solution designed to be trust minimized and secure, supporting not only just native BTC, but also its meta protocols. So this approach really sticks to the core principles of Bitcoin and enhances user sovereignty. But yeah, you might wonder why now and why we built using ICP's technology. Well, we believe the timing couldn't be better. We are witnessing a sort of Bitcoin renaissance. Bitcoin remains the top dog in terms of market cap and also popularity. There's a surge of developers and the community interest, and frankly, the market is eager to tap into Bitcoin's potential. As shown in the structure overview diagram on the right-hand side, all the core logic is realized in canisters on IC. Helpers and ledger smart contracts are deployed on supported blockchains, given they have VM capabilities. If they don't, we need to find other ways to realize that. As we all know, ICP offers some unique technologies, Chain Fusion, which is the topic today, and also Bitcoin integration, kind of like connected to Chain Fusion, and also HTTP out calls. These are vital for BitoBridge as well, similar to the projects I see today. These features allow us to build functionalities that would be quite challenging otherwise. So what's in it for IC's ecosystem? You know, like we think that we bring several benefits to the ecosystem. It is the pioneering Bitcoin omnichain capability within the Web3 space. Also, it supports bridging ICRC tokens across various blockchains, and also it showcases the practical use of ICP's Chain Fusion technology, as many of you do today. Awesome job. And lastly, it attracts successful collaborations and new users from other blockchain ecosystem to the ICP ecosystem. So about BitoBridge, as I mentioned in previous slide, is built on IC. Currently, it supports bridging native BTC and ICRC tokens to and among various blockchains. Ordinals and the runes will soon be integrated. If the market needs them, we may integrate other native tokens and standards such as CK Solana and CK Tang into BitoBridge. Our vibrant community actively engaged in BitoBridge V2 and used to engage in BitoBridge V1 testnet and provides valuable feedback and insights. So to now, like we have, we launched BitoBridge V1 testnet a month ago, and there are over 80K bridging transactions already. And as I said, we just upgraded to V2 several hours ago, and we will see the transaction data on V2 maybe, or we expect to see over 100K in the coming months, something like that. So a quick demo of V2. I don't know whether it's okay, should work. It is live now, so you can just visit it by visiting theapp.bitomni.io. It's our website, and all the features are available to all the users. So basically, you know, we have a wallet manager which manages all kinds of wallets, EVM wallets, IC wallets, and the Bitcoin wallet. And once users log in connected with those wallets, they can just do, you know, all kinds of bridging between any two of the chains we supported. And I think the user interface is quite clear. And for the bridging transactions, we have various transaction fees or protocol fees. And there are various waiting periods during the transaction, you know, depends on the target chain and the source chain you chose it. All the details of the transactions and link to the explorers are shown on the app. So now we are bridging up Bito, which is our test token from IC to StradoVM. StradoVM is a EVM compatible Bitcoin layer 2. So basically, you can just use EVM wallet to connect to the StradoVM network. And once the token arrived on the target chain, users can claim it using target chain's gas, token as a gas fee. So by doing this, we don't need to deal with XRC price fee, stuff like that. We just hand over all this process to the user's end. So now it's back from StratoVM to ICP. So yeah, it's quite simple actually. You just open up the app and see what blockchains are we supporting, and basically now what you can do is bridge Bitcoin and ICRC tokens to different blockchains using our product. So okay, let me go to the next slide. Market and community size is quite important. So about it. So about the market potential, Bitcoin's market cap is huge, way bigger than Ethereum's, yet it's barely tapped into DeFi. The chart on the left shows that Bitcoin market cap is about $1.2 trillion, and Ethereum's is about $300 billion. In terms of the size of DeFi, Ethereum has over $130 billion in TVL, but Bitcoin has almost none. So let's do a simple math. Ethereum's market cap is about a quarter of BTC's. BTC5 might just be like 4 times of Ethereum's DeFi, leading to an over $500 billion market. A product like a BitoBridge is the infrastructure for BTC5 markets with a significant potential. And looking forward, September is going to be a big month for us. We've launched the BitoBridge version 2 testnet just now, and we'll conduct various audits and aim to go live with the mainnet by the end of the month. Our roadmap includes more blockchain support and deeper integration with Bitcoin Meta protocols. We're all about collaborations and interoperability, not just technologically, but also in product development, marketing, and campaign partnerships across blockchain ecosystems that BitoBridge supports. We have a pretty good community. We have like over 70K followers on X and almost over 10K Telegram members in our Telegram group. So, and also one thing I want to mention at last is that there is an upcoming SNS for us. A quick note on our SNS plans. We've posted an article on the DFINITY forum to gather feedback a month ago. The timing of the SNS sale isn't set in stone yet. We're not rushing it. We value all the inputs from the community and also all the users, and would also love to hear your thoughts on this. So that would be all for me. Thank you, Jensen. Thank you, all the ICP hackers and builders. And thank you for having me here today.
Absolutely. Thank you, Ray, for being here. Thank you for sharing. And I'm glad to say that the jury have convened. We have went through a lot of the details, everything that's been shared today, and we're happy to move on to presenting the winners. Once again, thank you, Ray. And now we're moving on to the grand finale and the announcements of the winners. I will quickly get Jennifer back on stage, as she will be the one announcing. Give me a second, Jennifer. You should be seeing the invite.
Hello there, guys. Thank you so much for your patience while we, of course, listening to Ray as we are going to announce the winners.
Yeah, so as mentioned, there's a single bounty, which was the best use of Chain Fusion throughout the Internet Computer Chain Fusion Hackathon, and the rewards for the bounty were 10K, 2 issues of each in ICP developer grants. So Jennifer, Just to say, Jennifer was also accompanied by Elias and Emma, who were part of the jury from ICP, and Jennifer will have the honors of announcing their final decisions. So, Jennifer, who are the winners of the Internet Computer Chain Fusion Hackathon?
Yeah, we're happy to announce AstroApe and Oreka as the two winners of the bounty. And so congratulations. But that to say, we did really like all of the finalists. So we'll still reach out and see how we can help you guys. It's not just about winning the hackathon, but we do want to have a long-term relationship with all the finalists, and hopefully we can still have you build an ICP. So congratulations to both teams. But yeah, we're looking forward to working with you guys.
Congratulations, everybody. This was great. I'm really happy for all of you, and that all of your hard work has paid off in such a way. For those of you that didn't know anything, again, being part of a finale is a huge achievement, and you should all be happy with your journey so far. And I'm sure that the ICP community and team will be happy to support you on your development journey. One last thing to note is that all prizes are tentative and can be altered. Again, there's going to be additional due diligence that's going to be done by all teams. And in case something needs to be double checked, there might be alterations. But again, so just keep that in mind. Other than that, I would like to invite all of you back on stage for a nice photo so that we can commemorate this event with a nice smiley photo, which we can use and then show off on Twitter, basically. Getting your invites, get on stage, Devin, get on stage, Anthony. Getting you all invites. We'd love to have you also, Emma and Elias, on stage. So please come on stage for a nice photo. Elias coming in as well. Steve shooting up an invite. Ray, feel free to come as well. Slavik, Thomas, all of you, please make sure to come on stage. Exciting, huh, guys? Great to finally see you all and see some smiles. I know the last few days, and as we were doing the pitch practices, have been we're quite nervous, and there's been a lot of hard work done at the very last stages so that this event could happen. Again, thank you all. On 3, 2, 1, I'll ask one of my colleagues also as well to do a couple of screenshots as well. Thank you all. 3, 2, 1. Thank you all. Show me some smiles. Yes. Fantastic. Thank you all. Hope you enjoyed the event, and looking forward to see you among some of our future ones. And thanks again to the ICP team for supporting this fantastic event. Thank you all. Have a great day, and see you all around.